Before fireworks light up the sky, there's a process that's all about precision. Think of it like baking a complex pastry. One wrong gram of powder or metal salt, and the whole batch is ruined. The ingredients are measured with the same care you'd use for a tricky dessert, but here, a small mistake isn't just disappointing, it can be explosive. Firework making isn't just about mixing and hoping for the best. It's a step-by-step journey. Mixing dusty powders, assembling each shell, attaching the fuses, and running careful checks before anything gets shipped out. Every stage matters, and each one builds on the last. It all starts with the ingredients. If you're enjoying this behind-the-scenes look, make sure to like the video, subscribe for more, and let us know in the comments. Where in the world are you watching from? Cracking open the world of fireworks means getting up close with the building blocks that make every burst possible. The main explosive mixture is a blend of potassium nitrate, charcoal, and sulfur. Potassium nitrate supplies the oxygen, charcoal acts as the fuel, and sulfur helps everything react quickly. Each ingredient is measured to the gram, and the mix is handled with care that borders on obsessive. Pyrotechnicians wear anti-static gloves and use grounded tools, since even a tiny spark at this stage could trigger disaster. Safety isn't just a guideline, it's a requirement, and every movement reflects that. The process doesn't stop with the basic powder. To get those jaw-dropping colors, metal salts join the mix. Strontium salts make reds, copper salts are used for blue, and others like barium take care of green. Blue, in particular, is tricky. Copper compounds have to be just right, or the color fades. The tiniest change in temperature or ingredient quality can mean the difference between a perfect blue and a dull gray. This is where chemistry and artistry meet, and the people making these mixtures are constantly tweaking their formulas, chasing that perfect shade. After mixing, the next step is to turn these chemical blends into something manageable. The powders are combined with binding agents and shaped into small, uniform pellets. These are called stars. The binding agents help hold everything together and make sure the stars burn evenly. The size and consistency of each star are carefully controlled, since too big or too small means the effect won't work as planned. Each star contains the color and energy needed for a single flash in the sky, and their uniformity is key for a predictable display. And these pellets, called stars, are why we see rings, spirals, even smiley faces in the sky. The way they're arranged later will determine the shape you see during a show. But before any of that, the stars need to be dried and stored. Each batch is kept in separate, secure areas to avoid accidents. Some factories even ban certain machines, sticking with hand tools to keep the risk of sparks as low as possible. Watching this process feels a lot like a high-stakes kitchen, where a single slip could ruin the whole recipe, or worse. These stars might look small and simple, but they're packed with everything that makes fireworks so mesmerizing. The colors, the intensity, and the timing all start here. Once the stars are ready, they become the heart of the firework, waiting to be arranged in the next stage. Packing these explosive pellets into a shell, arranging them just right, and keeping the whole thing stable, now that's where the real challenge begins. Building the boom starts with a shell that's more than just a container. The casing is made from pressure-resistant paperboard designed to withstand hundreds of pounds per square inch until detonation. This sturdy shell is what keeps all the explosive energy trapped inside, ready to be unleashed at just the right moment. Inside, the assembly gets technical. At the very center sits the main charge, an explosive core wrapped in paper that acts as a simple timer. Around this, color-producing pellets, or stars, are arranged with care. The pattern you see in the sky starts right here. A ring of stars gives you a classic circle. A scattered cluster creates a peony effect. For more complex shapes, like a heart or a smiley face, the arrangement is mapped out with geometric precision. Imagine arranging pellets in a smiley pattern here. When it bursts, it draws that shape against the night sky. But it's not just about looks. The inside of the shell is layered with shock absorbers and spacers, think cardboard rings and pressed paper discs, that protect the stars and core from the first explosion's force. In some designs, there are 2 or even 3 compartments, each with its own set of stars and a small burst charge. These compartments are separated by spacers that delay the next burst by about 1.5 seconds, letting one effect finish before the next begins. This careful layering is what gives you those multi-stage fireworks that change color or shape mid-air. Each star is checked for size and consistency before it goes in. If the stars are too big or too small, the pattern won't show up right. The shells are packed tight to make sure the pressure builds evenly. The tighter the shell, the bigger and brighter the explosion. The central core must stay stable, and every layer is secured with just enough adhesive to hold during launch, but not so much that it blocks the explosion. Comets and other decorative inserts get added next. These little extras, like magnesium for white flashes or charcoal for orange trails, bring more variety to the display. The pyrotechnician chooses the right combination to match the show's design, making each shell a custom creation. Safety is constant during assembly. Technicians work in rooms with grounded tools and anti-static gear. Shells are moved by hand, not by machines, to avoid accidental jolts. Each assembly area is isolated. If something goes wrong, it won't trigger a chain reaction. Color-coded labels are added for easy identification, and every shell is inspected for flaws before it moves on. Once packed, the shell moves on to its crucial timing stage. The next step decides when the firework will burst in the sky, and that means it's time to talk about fuses. Timing is everything in fireworks, and that precision comes down to 2 simple-looking components: the main fuse and the time delay fuse. The main fuse is what gets the show started. It's carefully glued into the base of the shell, making a secure connection to the lift charge, a bag of gunpowder that launches the firework into the air. Workers dye the fuse adhesive blue, so even in low light they see exactly where it's applied, a detail straight from the research floor. Once the main fuse is in place, the time delay fuse goes inside the shell. This fuse is routed through different compartments and layers, burning at a controlled rate to trigger each burst at just the right moment and altitude. The time delay fuse isn't just a string. It's a carefully engineered piece that burns at a precise speed, measured down to fractions of a second. If it's even a little too fast or too slow, the firework might burst too early or too late, throwing off the entire display. Inside the shell, the fuse weaves through the stars and burst charges, sometimes connecting multiple compartments for those multi-stage effects. Each segment is measured and cut to match the exact timing needed for the show's design. In big shows, computers can light these fuses in sync with music, adding another layer of choreography to the spectacle. Assembly at this stage is all about control and care. Workers wear anti-static gloves and hand-carry shells between stations to eliminate jolts or sparks. Every step is deliberate. No rushing, no shortcuts. Color-coded labels go on each shell, showing the size, type, and power of the explosives inside. These labels make it easy for technicians to identify and sort shells safely, and they're essential for storage and transport. Before sealing the shell, the lift charge is attached to the base. This small but crucial bag of black powder is what gives the firework its launch power. Too much powder and the shell could explode before reaching the right height. Too little, and it might not leave the ground at all. The lift charge is wrapped and secured so it stays intact during handling, storage, and shipping. Once everything is assembled, the final prep begins. Each shell goes through a detailed inspection. Fuses are checked for secure placement. The shell is examined for structural integrity, and every component is double-checked for flaws. The time delay fuses are tested in advance to make sure they burn at the correct speed. Only after passing these checks does a shell get wrapped in craft paper and labeled for shipment. These steps are what make sure every firework is safe, reliable, and ready to perform. Next, we'll see how these precisely timed shells are quality checked before shipping around the world. All this effort ensures that when a firework is launched, its timing and performance are the result of careful planning, not chance. The result is a display where every explosion is deliberate, a blend of chemistry, engineering, and attention to detail that sets the stage for the final show. When you watch a firework bloom overhead, you're seeing science and craftsmanship working together. Each shell is the result of careful measuring, mixing, and assembly, hours of work for just a few seconds of light. The combination of chemical reactions and hands-on skill is what makes every display unique. Some manufacturers even experiment with eco-friendly salts and biodegradable casings to cut smoke and debris. The industry is starting to look for ways to make fireworks cleaner, showing that innovation keeps moving forward. If you love discovering how things are made, hit like and subscribe for more behind-the-scenes stories. Every burst now has extra meaning, science and craftsmanship lighting up the sky.